For 2.1, we are going to start learning about rational numbers. Now, the definition we're going to see in just a second is a little bit confusing, but we're going to walk through it and break it down. So we've learned about integers, so the positive and negative numbers that are whole. 1, 2, 3, 4, 5, -1, -2, -3, right? Whole numbers. So we're going to take it a step farther now. So we've only talked about whole numbers. So rational numbers are written in the form a over b. So they're a fraction. So that's what that says, is they're written as a fraction, or they can be. A and b have to be integers. So you can't have 0.5 over 7. You can't have a decimal and a fraction combined together. So these are both whole numbers. It's like 3 over 4, 7 over 8, 9 over 5. You can have an improper fraction. It just needs to be written as a fraction. And b cannot be 0. So you can't have 4 over 0. So make sure you have your definition written down, and then we're going to break it down a little bit more and practice that. So if you're confused, that's okay, right? We have integers, positive and negative whole numbers. Now we're just including some decimals and fractions. So this is something we're going to write a little note to ourselves. It's just written as a decimal, and it has an ending. It's like 0.75, 0.9236. But if it goes 0.539218563 and it just keeps going forever and ever and it never ends, that's not a rational number. That's another type of number you're going to learn about later in math, not this year, okay? So rational numbers are just fractions and decimals, and they're just nice fractions and decimals, like your benchmark ones, 1/2, 1/4, okay? So nice ending decimal numbers. So rational numbers, we're going to look at a few ideas and put some examples here. And we are going to put them with the vocabulary words just to connect and show what that's like. So 0.35, it's a decimal and it ends. It can also be written as a fraction. This is 35 out of 100. So make sure you have that, right? It can just be written as a fraction or an ending decimal. Now 6 is an integer. It's a whole number, but it can be written as a fraction. 6 over 1. 6 divided by 1 is 6. I could write it as a decimal, 6.0. So 6, it is an integer, but it's also a rational number. So, right, rational numbers include the integers and the fractions and decimals. So now we have -4/5. That's a fraction already, so we can see it's rational, but it could also be written as 0.8. It's 80% of the whole number, 0.8. And here we have 8.942. So it is a decimal. It's not a nice one, but it ends. So I could write that as 8 and 942 out of 1,000, because that 2 is in the thousands place. So it can be written as a fraction, and it's a nice ending decimal number. So there we have some, to go with our definition that was a little bit confusing, we have some examples to demonstrate that there. And then go ahead and draw 3/4 and shade it in. So here's another example of a rational number. So it's just a nice fraction that we can shade in. That 3/4 is a rational number. We could also make it -3/4, still a rational number. Okay, so we're going to identify where -2.6 would be on this number line. So we know it has to go backwards because it's negative, and it has to be in the twos. So if we're looking here, so here's a half, here's 1, 1.5, so these are all negatives. Here's -2, but then I don't want to count 6 this way, right? So if I'm looking here from 0 to -1, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces between 0 and the whole number, between 1 and 2. So that means each of these little places is 1/10. And we have 6/10. So we need to be at 2, and we need to go into the negatives 6/10 more. So we're here at 2. So here's 2.1, 2.2, 2.3, 2.4, 2.5. 2.6 is right here. Now we're going to make a little statement. What do we know about negative 2.6? So negative 2.6 is between the integers blank and blank. So integers are whole numbers. So if I'm looking forward, my closest whole number is 2. So it's between negative 2. And if I'm going backwards more, my closest whole number is negative 3. So it is between 2 and negative 3. So negative 2 point, so we know where it was, and we know it's to the blank of 0. So we were here at 0, and we know we had to go to the left because it's negative to get to that number there. So we know it's to the left, and we know it's between negative 2 and negative 3. So that gives me a good idea of where I should put negative 6. Okay, get that listed in your key ideas to help you remember, right? I need to look at the positive or the negative, and I need to think about the integers that it needs to be between. Okay, we're going to do some examples. You need to make sure you are doing the work with me, not just writing down my answers. Students that are doing the work as you're supposed to are going to learn more. So we have this number line up here just to kind of help us think and compare them. So we're going to be writing some inequalities to compare these rational numbers. So I notice these are both negatives, right? If you have one that's positive and one that's negative, the positive will always be more. These are both negatives. So this one, we have negative 1 and 8/10. So here's negative 1.5, 1.6, 1.7, 1.8. So there's 1.8. And then this is negative 3.4. So negative 1, negative 2, negative 3, 0.1, 0.2, 0.3, 0.4. So remember, this way is always getting smaller. And this, the one that's more to the right, is going to get bigger. So even though negative 1.8 is negative, this one is even more in the negative, so it is smaller. So you have to pay attention to those negative signs, because if we just think about 3.4, that sounds bigger. But because it's negative, it means that person actually has even less money. They owe somebody more money. So we're going to write our inequality. So negative 1.8 is greater than 3.4, or I can read it backwards. Negative 3.4 is less than negative 1.8. Okay, our next one, we have 3/6 and 1/4. So this time these are both positive. So they're going to be on the right of 0. They're both less than 1 though. So we've got to figure out where would they be. So we've used a number line to help us. This time we're going to try a different strategy. So I'm going to start, and we're going to make them common denominators. But I'm going to simplify this one first. So what do I know about 3/6? Sorry, I need a smaller green pencil. Okay, 3/6, 3 is half of 6. So this is actually 1/2. 3 divided by 3 is 1. 6 divided by 3 is 2. 1/2. So now we have 1/4 and 1/2. Now I can change 1/2 into 1/4. How do I get from 2 to 4? I times by 2. So I do the same thing to the numerator. 1 times 2 is 2. So this one has 2/4. This one is only 1/4. This one has more pieces than this one. So this one should be bigger, right? This one is a half. This one, or I could write it as a decimal. Whoops, didn't go over far enough. 0.5. This one says 1/4. 1/4 is only worth 25 cents. This one is worth 50 cents. So we can make common denominators. We can compare them, change them into decimals. That's my favorite way. Or I could even, because these are both pretty easy, I could draw a picture. So here's 1/2, and this one is 1/4. So I can see, right, this one is more than that one. So 3/6 is greater than 1/4. 1/4 is less than 3/6. So forwards and backwards, so make sure you have the proof as well. And our last one is negative 1.75 and negative 1/8. So before we had decimals and decimals, fractions and fractions. This one is a tiny bit different. We have a fraction and a decimal. I notice they're both negatives. So now we got to think about which one is farther into the negatives to be smaller. So here we have negative $1.75. So we're going to start and we're going to write that as a fraction. We're going to change them both into fractions to start. So we have negative 1 and 75 out of 100, because that's in the hundredths place, 75 cents out of 100 pennies. Now this one, we are not sure yet because we don't talk about money in eighths. So we're going to change it into a hundredth like this one here. So I need to first know, how do I get from 8 to 0? So how many times does it take to get from 8 to 100? So I know 8 cannot go into 1, but it can go into 10 one time. So 1 times 8 is 8, and there's 2 left over. Now we have that 0 here. So 8 goes into 20 2 times, which is 16. Now we have 4. We're going to add a decimal and a 0. Same thing, it's still 100. 8 goes into 40 5 times. So 8 times 12.5 equals 100. So we're going to times by the same thing up here. 1 times 12.5 is 12.5. So this one has 75 cents. This one has 12.5 cents. So I can see that this is smaller, but they're both negatives. So we need to think about where they would be on the number line. So here's negative 1. Here's negative 1.5, 1.6, 1.7, 1.8, right? We want right in the middle there, 1.75. And then this one is negative 1, and here's 10. So like here would be 12 right here. So I can see that even though this is negative, it is more to the right. So this one right here is bigger. So negative 1 and 1/8 is greater than negative 1.75, or I can read it forward. Negative 1.75 is less than negative 1 and 1/8. So using a number line, using common denominators, changing them to decimals, drawing a picture, those are all the strategies we have that we can use to compare those rational numbers. Hey, if there's anything else you need to add, I know we already added one thing together about decimals and how they end. If you have anything else you want to add here, maybe about some of those strategies we just talked about, pictures, common denominators, decimals, right? Maybe you could add those there to help remind yourself how we can compare them.